I'm studying a group of disorders called skeletal dysplasias. And skeletal dysplasias affect how bones grow and develop. Everybody who has a dwarfism has a skeletal dysplasia, but not everybody with skeletal dysplasia has dwarfism. Now we're interested in finding new genes that cause skeletal dysplasias, but also in developing better tests to detect mutations in known genes with skeletal dysplasias. So my background is as a genetic counselor, and I came here as a study coordinator on the skeletal dysplasia project. And when I got here, I was predominantly recruiting patients, taking family histories, medical histories, etc. And as I was here, I realized that nobody was available to analyze the data that was coming out of the sequencing results. And so I asked Paul Leo, our bioinformatician, if he could teach me how to analyze this data. He said, sure, no problem. So I started analyzing it, and I started finding genes. And I found it was so exciting, this whole element of Sherlock Holmes, this gene interacts with that gene, and that gene is known to cause this condition. So I got hooked. And I got more and more drawn into the research side, to such an extent that the powers that be persuaded me to do a PhD. And my PhD is on skeletal dysplasias and finding new genes and using the techniques available to offer better genetic testing. And as a genetic counselor, having spent so many years going, we think you have this condition, but unfortunately we're not able to offer you genetic testing for it, it's very, very satisfying to think that this might result in better genetic testing for people. I'm very excited about the impact that this research could have. If you can think about it, if we find new genes that cause abnormalities in bone growth and development, it's going to give us a lot more opportunities when we think about treatment and prevention in a lot of these conditions. I'm also interested about the genetic testing side of things. The idea that we're working to develop techniques which allow us to sequence all 30,000 genes in one step. We're going to be able to sequence people with rare disorders and look pointedly at the genes that we know of and say, we've scanned these 150 genes in one step, we know you carry a mutation in that gene. And that's incredibly powerful for these families and individuals as they think about, future family planning and just coping and adapting to genetic conditions.